Evening, welcome to the problem solving session for the course Environmental Remediation of Contaminated Sites. So, we have already covered all the lecture materials and the questions based on previous assignment questions. For each week, we have solved. So, in this problem solving session, we'll try to solve few numericals. Um, this is basically a recap of the numericals which we have solved during doing the previous year assignments. So, I will directly share my screen. I will share some of the questions, similar type of questions which I have already solved, and try to solve this question. So, let me first share my screen. Let's go to the first question. So this question is to find out the hazard index. So we have seen in I think week 2 or 3 for finding out the risk related to carcinogenic compounds and the hazard index of non-carcinogenic compound. So we have seen that two approaches are used. First is the deterministic approach, and next is the stochastic approach, where statistics are involved. So here, this is the question to find out the hazard index for three heavy metals, that is cadmium, lead, and mercury. The reference dose are given, and the daily intake of these heavy metals are given, and we have to find out the hazard index. So, so hazard index for non-carcinogenic compounds are given as average daily intake divided by the reference dose. So the daily intake is given and also the reference dose is given. So we will find out the hazard index for each heavy metals, and then we can find out the overall hazard index by summing the hazard index of individual. So I'll give you 5 minutes. Please try to solve the question and write the value which you are getting in the chat box. Let's see what values we are getting for the hazard index. So hazard index is given as daily intake to reference dose. So, so the hazard index for all these three heavy metals will be the sum of hazard index for each. So it will be hazard index for cadmium plus hazard index for lead plus hazard index for या फिर or hazard quotient for mercury. So for cadmium, daily intake is given as 8.5 into 10 raised by minus 2. Reference dose is 4.5 into 10 raised by minus 4. Similarly, we can find for cadmium, sorry, for lead and for mercury. Solving these, we are getting hazard quotient as 4573.6. So since the hazard index is greater than 1, then these pollutants are above the limit and they can cause damage to the humans and other organisms. So this much concentration of these three heavy metals is toxic. So now let's move to the next question. So the question is calculate the risk due to the following carcinogens. So three carcinogens are given, slope factor and the average intake of these three carcinogens are given, and we have to find out the risk. So risk is given as slope factor into average intake. So again, I'll give you 5 minutes. Please try to solve these questions and write the value which you are getting in the chat. So risk is given as average intake into slope factor for that pollutant. So the overall risk for these three contaminants will be sum of risk for each contaminant. So risk for chlorobenzene plus risk for benzene plus risk for BHP. Now here, so for BHP, no slope factor is given, so we'll take it as 0. So this risk will be 0. So we have average intake for chlorobenzene is given and its slope factor is also given. Similarly, it is given for benzene. So on solving this, we can get the risk as 17.5 into 10 raised per minus 12. So the risk is less than 1 in a million. So these three carcinogens at these concentration are less likely to cause cancers in the humans. So the answer is 17.5. Now let's move to the next question. So the question is, a drinking water supply is found to contain zero point 0.2 milligram per liter of acetone and 0.15 milligram per liter of chloroform. A 70 kg adult drinks 2 liter per day of this water for 5 years. What would be the hazard index and the carcinogenic risk from drinking this water? So in the previous two questions, we have calculated the hazard index and the risk. Now for this question, we have to find out the hazard index and risk for acetone and chloroform. So first we will find out the average daily dose of these two pollutants. So please try to solve this question. So this is the formula to find out the average daily dose. So the average daily dose will be the concentration of the contaminant into ingestion rate. So the ingestion rate is given as 2 liters per day. That person is drinking the water. So this is the ingestion rate. So exposure duration is for 5 years and exposure frequency is daily he will drink water. So 365 days a year divided by body weight is given as 70 kg and then averaging time. So for non-carcinogenic compounds, averaging time will be exposure duration into exposure frequency. But for carcinogenic compound, the averaging time will be the lifetime of that particular person. That is generally taken as 70 years. So please try to first find out the average daily dose and write what you are getting, and then we'll try to solve this. Let's see how to find out the average daily dose. So for chloroform, first let's find out for acetone. So concentration is given as 0.2 milligram per liter. Ingestion rate is 2 liters per day. Exposure duration is 365 days for 5 years. Body weight is 70 kg. And averaging time will be 365 days a year for 5 years. So it's coming out to be 5.71, 4 into 10 to the power minus 3. So for chloroform, average daily dose will be it's 0.15. Everything else will be same. Ingestion rate is 2 liter per day. Five years, 365 days a year. On solving this, we are getting 4.8. And also one more statement, reference dose for acetone is 0.1 milligram per kg per day. And for chloroform, It is 0.01 gram per kg per day. These are in milligram per kg per day. So the hazard index for acetone will be, so the hazard index is 4.86, which is less than 1. So these two contaminants at this concentration is not toxic to humans. Also in the question, carcinogenic risk has to be calculated, but the slow factor is not. I have not mentioned the slow factor. So for carcinogenic groundwater site, groundwater at a site is contaminated by dichlorobenzene with a concentration of zero point 0.2 ppm. The volume of the contaminated soil is given, the pumping rate of water is given, porosity is given. We have to calculate the time required in days to pump the contaminated groundwater. Assume that the concentration in the pumped water is 30% of the concentration in the contaminated tube. Assume the contaminant is present only in the aqueous phase. So we have to find out the time required to remediate the site. So again, I'll give you 5 minutes. Please try to solve this question and write the value which you are getting. So let's see how to solve this question. So the time required to remediate. So the time required to pump the contaminated groundwater will be the mass of contaminant divided by pumping rate into concentration of contaminant in pumped water. So the mass of contaminant can be given as porosity into volume of the contaminated site into the concentration of the concentration of the contaminant in the plume divided by pumping rate into the concentration of contaminant in pumped water. So the time required will be, we have porosity as 0.5, volume as 80,000 cubic meter. Concentration of contaminant is 0.2 milligram per liter. Pumping rate is given as 1000 liter per hour. So we will convert into meter cube per hour. So that will be 1 meter cube per hour into concentration of the contaminant is pumped water, which is 30% of the concentration in the contaminated plume. So 0.3 times of 0.2. On solving this, we will get the time in hours. So we can convert it into days, which is coming out to be 5,555.55 days. So this much time will be required to remove the dichlorobenzene from this aquifer if it is present only in the aqueous phase. So let's move to the next question. So the question is, a site is contaminated with TCE. The source zone is 350-meter long, 80-meter wide, and 220-meter deep. Organic matter fraction is 3%. Soil water partitioning coefficient is given. Porosity is given and bulk density is given. We have to find out the value of retardation factor. So again, I'll give you 5 minutes. Please try to solve this question and write the value which you are getting. To solve this question, so retardation factor when there is partitioning or absorption of the pollutant with the sediments, retardation factor is given as 1 plus Kp rho v by porosity. So the partitioning coefficient So partitioning coefficient is given and FOC is given. So KP is KOC into FOC. So KFC is 200 liter per day. So liter per kg and organic fraction is 3%. 3%, which will be 0.3. So it will be 6 liters per kg. So bulk density of soil is given, porosity is given. So we can find out the retardation factor as 1 plus 6 liter per kg and bulk density is 1.73 kg per liter. So liter per kg and kg per liter will cancel out and porosity is 0.4. 26.95. So this is the retardation factor. So I hope this question is clear to you. So let's move to the next question. Again, we have to find out the retardation factor. A site is contaminated with PC with an aqueous concentration of 15 gram per meter cube. The source zone is length, width, and depth is given. Organic matter fraction, soil water partition coefficient, porosity, and density of soil is given. And density of pure NaPl is also given, and it is present in 4% of the pore space. We have to calculate the retardation value. So in the previous question, no NaPl was present, only pollutant was present in water and sorbed in the soil or sediment particle. But in this question, NaPl is also present. So we have to find out the retardation factor. So let me just give the formula to find out the retardation factor. The rho B is the bulk density of the soil, Kp is the coefficient which we'll find out from soil water partition coefficient and organic fraction. S is the percentage of the pore space which is occupied by NaPl, which is 4%, so 0.04. Rho density, void rho ratio is given, porosity is given, and rho NaPl is the density of the NaPl, and C naught is the initial concentration of the contaminant in the aqueous space. So everything is given, we just have to put in the formula and we can find out the retardation factor. So again, I'll give you 5 minutes. Please try to solve this question. See what value I get when I get the adaptation factor. So density of the soil is 1900 kg per meter cube. Kp will be KOC. KOC is given as 125 ml per gram. 125 into organic matter fraction is 1%, so 0.01. This much ml per gram divided by 1 minus S percentage of the pore space, which is occupied by NaPl is 4%, so 0.04. Porosity is 0.4. So 1623 kg per meter cube. So it will be gram per liter. So to convert into a gram per ml, we will divide by 1000. This much of gram per ml. Again, percentage of the pore space occupied by NaPl is 4%, so 0.04. Density is 1623. This is gram per liter. 1 minus 0.04. C naught is 15 gram per meter cube. So 15 by 1000 will give us gram per liter. So by solving this, we will get the retardation factor. Five hundred. It's coming out to be 4515152. Let's move to the next question. Question is, a site is contaminated with PC with an aqueous concentration of 15 gram per meter cube. The source zone is 200 meter long, 50 meter wide, and 10 meter deep. Organic matter fraction is 1%. Soil water partitioning coefficient is 126 ml per gram. Porosity is 0.4. Bulk density of soil is 1900 kg per meter cube. Pure NaPl is believed to present in 3% of the pore space. The total mass of contaminant is. So we have to find out the total mass of the contaminant. So the total mass of contaminant will be given as the sum of the contaminant in each phase, that is in the aqueous phase, then in solid phase, and then in NaPl. So S is given as 3%. C naught is 15 gram per meter cube. Porosity is 0.4. Volume will be 200 into 50 into 10. Kp will be FOC into KOW. Q will be Kp into C naught. And by putting all these, we can find out the total mass of contaminant. So again, I will give 5 minutes to do the calculation. Please do the calculation and write the value. That's all. So let's first write what is given. Percentage of the pore space occupied by NaPl is 3%, so S will be 0.03. Concentration in the aqueous phase is 15 gram per meter cube, which will be 15 by 1000 gram per liter. Porosity is given as 0.4. Volume of the soil or contaminated soil will be length into width into depth. This 200 into 50 into 10 is coming out to be 100,000 meter cube. Kp will be KOC into FOC. So KOC is given as 126. Six ml per gram. Fraction of organic fraction is 1%, so 0.0801. So it is 1.26 ml per gram. And Q is given as Kp into C naught. So Kp we have calculated as 1.26 ml per gram. So ml per gram, if we will convert it to liter per kg, then it would be like this only, into 15 by 1000 gram per liter. So to convert gram into kg, again we will divide by 1000. So this will be kg per liter. So overall we are getting as 18.9 into 10 raised to minus 6. So the mass of the contaminant will be 1 minus 0.03. Porosity is 0.4. Volume is 100,000 meter cube. Into 15 by 1000 gram per liter. Plus density is 1900 kg per meter cube into 18.9 into 10 raised to minus 6 is kg into volume is 100,000 meter cube. Plus S is 0.03, porosity is 0.4, volume is 100,000 meter cube, density is 1623 kg per meter cube. So here meter cube will cancel out, and in the first uh, for mass of contaminant in aqueous phase, so this is meter cube, and to convert gram per liter into kg per meter cube, we will multiply and divide by 1000, so it will be cancelled out. So on solving this, we are getting 582 plus 3591 plus 1947600 kg. Overall, it is 1951773 kg. So we can convert it into tons by dividing by 1951.773 tons. So this is the overall mass of the contaminant TCE. So next move to the next question. So the question is, a plume is to be retarded by permeable reactive barrier is 200-meter long, 1 and 10-meter deep. Aquifer porosity is 0.35. PRV porosity is zero point 0.4. K for PRV is 0.28 per hour in field. TC maximum concentration is 10 ppm. And target concentration is 2.5 microgram per liter. And the concentration of zero valent ion in batch reactor is 125 gram per liter. So question is, consider that the system behaves as a pseudo first order system with a rate constant of 0.28 per hour. The retention time required in the PRV for the same effluent and remediated waste water concentration in hours. So we have to find out the time required for the for the effluent to stay in the PRV to reduce the concentration from uh, 10 milligram per liter to 2.5 microgram per liter. So we have to consider the system is reacting as a pseudo first order system. So we have solved similar questions in the previous weeks. So please try to solve this question. I'll give you 5 minutes to do the calculation and then we will see how to solve this question. For pseudo first order reaction, so concentration at any time is given as C naught e raised to the power minus k theta, where k is the reaction rate constant and theta is the time. So we have Ct as 2.5 and C naught is 10. So 10 into 1000 will be this much microgram per liter. K is given as 0.28 and we have to find out theta. So on solving this, we can get the time required, which is coming out to be 29.6 hours. So this much time will be required for the water to stain the PRB to reduce the concentration of the TC from 10 milligram per liter to 2.5 microgram per liter. So these were the questions, extra questions which I have added from the previous weeks. So I hope the questions are clear to you all. So if you have any doubt, then you can ask, or else we can end the session here.